Good day, dear friends. My name is Evgeny Proskrin. I'm the founder of ATF Group. This is an engineering and manufacturing group of companies that started in a garage, producing hardware for transformers. And now it offers digital solutions for a wide range of industrial sectors. Today we are launching a series of micro lessons to share practical knowledge and help our energy sector operate more reliably, efficiently, and safely. After all, our mission is simple: your energy under our protection. Last time, we discussed thermal conditions in transformers and why they are critical for reliable equipment performance. Even a slight temperature increase can drastically shorten the life of the insulation. Today, we'll go deeper into the topic of loads. We'll define the different types, look at what happens during overloads, and how they affect a transformer's service life. A transformer's load is the power it delivers to the grid. It's not just an abstract number. It's the actual energy consumed by the connected equipment. There are several types of loads. Rated load, the maximum continuous power the transformer is designed to handle. Constant load remains unchanged throughout the day. Variable load fluctuates over time. Peak load, a short-term spike in demand. Why does this matter? Because each type of load affects the heating of the windings and oil differently. Transformers operate in either normal or emergency modes. Under normal conditions, load may vary but remains within safe limits. Under emergency conditions, a temporary overload may be allowed, but only with proper calculations and monitoring. Why are overloads dangerous? Insulation is like the immune system of the transformer. The higher the temperature, the faster it ages. For example, at 98 degrees Celsius, insulation may last 20 years. At 110 degrees, only 10 years. Every overload shortens the equipment's life. How do we evaluate acceptable load? Imagine a graph showing the relationship between transformer load and oil temperature, or a table with allowable load factors for different cooling methods. It's like a weather forecast. It helps you decide if the transformer can safely be pushed harder right now. Let's look at a sample calculation. Suppose we have a 100 megavolt ampere transformer. The oil temperature is 70 degrees Celsius. The allowable factor is 1.2. This means we can temporarily increase power to 120 megavolt amperes. But afterward, the load must be reduced to avoid overheating the system. Now let's apply this. Take a transformer from your substation or from your training manual. Answer 3 questions. What type of load does it handle throughout the day? Are there peaks? When do they occur? If the oil temperature reaches 85 degrees Celsius and the load factor is 1.1, how much can you increase the power? And for how long? Write down your answers, then compare them with the standard load duration tables. Is your current operating mode safe? Today you've learned what types of transformer loads exist, why overloads are dangerous, and how temperature directly affects insulation lifespan. In the next module, we'll explain how to calculate allowable loads and which standards and guidelines are used in the process. Want to explore the topic in more depth? Visit our website. The link is in the description. Interested in real-world solutions and industry challenges on this topic? Contact us. Our details are on the screen. Want to become a part of the global energy flow? Reach out to us. You'll find our contacts on the screen.